Okay, welcome back, folks. Quadratic functions and equations, lesson 6, solving quadratic equations using the quadratic formula. So we know that we can deal with quadratics by using the square root method, completing the square, and now we're going to learn a quadratic function. Okay. So it says, what does it say? It says, in previous lessons, we've determined the roots of quadratic equations by graphing and factoring and using inspection or decomposition. We learned the other day about the square root method. We have a bit of an idea of some completing the square method. And then we have a new one called the quadratic formula. Just as a review though, solve the equation 3x squared plus 13x minus 10 by graphing. Use a sketch to illustrate your solution. So into Desmos I go. Waiting for Desmos to load. There we go. And I'm going to put in my equation 3x squared plus 13x minus 10. There's our quadratic. Squish it to see it all on the same page somehow. There we go. There we go. There's our quadratic. And again, by using Desmos, I can just simply touch right there. It's going to tell me that my roots or my zeros or my x-intercepts or my solutions are -5 and then looks like 2/3. -5 and then 2/3. So we can go back to our graph here and we can very quickly sketch that and say, well, you know what? It kind of looked like this. This being -5, this being 2/3, comma 0, -5, comma 0. Oh, I didn't look to see what the y-intercept was. That might be a good tidbit. It looked like 10, -10. And then this was -10. Come on. 0, -10. So 3 points that we were able to get from our graph on Desmos. Solve the equation 3x squared plus 13x minus 10 equals 0 by graphing. Sketch your solutions. Well, x equals -5 and 2/3. Example 2, solve the following equations by factoring. We can factor x squared plus 7x minus 18 by inspection. Two numbers that multiply to -18, add to +7, that's 9 and -2. This becomes x plus 9, x minus 2 equals 0. I use my zero product law, x plus 9 equals 0. Solve for x, -9, x equals 9, -9. I go x minus 2 equals 0, add 2, x equals 2. So there's my solutions. Doing the same process or a similar process with 3x squared plus 13x minus 10, except this one, I'm looking for two numbers that multiply together to give -30, add together to give +13. Remember, this number comes from 3 times -10, and this one is this one. My numbers are -10 and -3. So now I'm going to decompose. 3x squared minus 10x minus 3x minus 10. Factor by grouping gives me x bracket 3x minus 10. And -1 gives me 3x plus 10. Uh-oh. Uh-oh. Oh, that's not right. Can't be -10 and -3 because that doesn't add to +13. Wow, that's not right. Too fast, Tommy. I'm gonna slow down. This has got to be +15 and -2. That's better. 3x squared plus 15x minus 2x minus 10. Factor by grouping. 3x, x plus 5, -2, x plus 5. There we go. X plus 5 is one factor. My other factor is 3x minus 2. Those equals 0. Using my zero product law, x plus 5 equals 0. minus 5, x equals negative 5. There's 1. 3x minus 2 equals 0. Add 2, 3x is equal to 2. Divide by 3, x is equal to 2 over 3. So that's what we had found previously from our graph. So you can see that these are the same polynomials. Okay. We go over the page. The solution to the equation x squared equals k is found by taking the square root of each side, and you get that plus or minus version. I've talked to a couple of you about that already. So this is another way to do it if you have certain forms of the polynomial. 3x squared, whoops. 3x squared is equal to 27. I'm going to divide by 3. That gives me x squared is equal to 9. I'm going to square root both sides. That's why it's called the square root method. Square root both sides. But when I square root, that gives me a plus and a minus version of 9, square root of 9, which I know is plus or minus 3. So your solutions are plus and minus 3. Oops, not 3 there. That's super x. You can do a similar process with others. You just have to make sure that you're following the steps properly. 2x minus 1 all squared is equal to 64. If I square root both sides, I'm going to get 2x minus 1 is equal to plus or minus 64. Square root of 64. Well, the square root of 64 is 8. So this is 2x minus 1 is equal to plus or minus 8. And I continue to solve. 2x, I'm going to add 1 to both sides. 2x is equal to, actually I squished that too far. Squished that too much. Add 1. No, this is where you have to be careful. 2x is equal to 1 plus or minus 8. I can't combine those right now. I have to get it all finished. Divide by 2. That gives me x is equal to 1 plus or minus 8 over 2. And I do both versions. I do the plus version. 1 plus 8 divided by 2 is 9 over 2. And I do the minus version. 1 minus 8 over 2 is negative 7 over 2. There's your two solutions. And then one last example. X plus 3 squared minus 8 is equal to 0. I'm going to add 8 to both sides. That gives me x plus 3 squared is equal to 8. I'm going to square root both sides. Gives me x plus 3 is equal to the square root of 8 plus or minus, which I also know is plus or minus square root or 2 root 2. Now I'm going to subtract 3. X is equal to negative 3 plus or minus 2 square root 2. And you could leave that right there. And if they wanted the decimal value, then they may ask you for the decimal value. So we've done work with all of those in the past. We've also done some work with completing the square method. So this is continuation, kind of an extension of example 3C. Which one was 3C? Oh yeah, that one, okay. Explain why the quadratic equation 3x squared minus 12x minus 8 cannot be solved by factoring. Well, you would have to try to factor this. You'd look for two numbers that multiply together to give 24, negative 24, but add together to give negative 12. And there are no numbers. Your choices are 1 and 24, 2 and 12, 3 and 8, 4 and 6. There's not one pair of those numbers that I can combine in any way to get 12. So this is not factoring, not factorable. So because it's not factorable, you would have to try other methods. One of those methods would be completing the square, okay, or the square root method. Solve this equation, 3x squared minus 12x minus 8 equals 0 by expressing the left side in completed square form and then using the square root method to complete solving the equation. So we first have to complete the square.
Maggie radioing to the office, please, for a message. Maggie radioing.
Sorry about that, guys. Now you can tell I'm at school. But we'd have to use the square, we'd have to complete the square and then use the square root method. So let's complete the square. 3x squared minus 12x minus 8. Put a bracket around first two terms because there's a 3 out in front. I'm going to take out a GCF of my 3. So remember, this is all equal to 0. I just didn't write it. There we go. This is going to be 3 bracket x squared minus 12x minus 8 equals 0. I want to add or subtract. Minus 12x plus something minus something bracket minus 8 equals 0. I want to add and subtract something. Oh, that's not 12. That should be 4 divided by 3. I'm going to divide this by 2. And then I'm going to square it. Add and subtract 4. I can't have that minus 4 on the inside of the bracket, so I have to take it out. I'm going to go minus 4 times 3, and I'm going to write it over here. Not on the other side of the equal sign. On this side of the equal sign, right after the 8. X squared minus 4x plus 4 bracket with a 3 minus 8, and then minus 4 times 3 is minus 12 equals 0. This should be a perfect square. 3 bracket x minus 2 squared minus 20 equals 0. Now we can solve this by perfect square method like we did here. Add 20 to both sides. 3 bracket x minus 2 squared is equal to 20. Divide by 3. X minus 2 all squared is equal to 20 over 3. Leave it as a fraction. Square root both sides. X minus 2 is equal to plus or minus the square root of 20 over 3. That's where we're at. X minus 2 is equal to plus or minus the square root of 20 over 3. Add 2, x equals 2 plus or minus the square root of 20 over 3. And again, you can leave your answer there as an exact value, or you may be asked for the decimal value. So you'd have to calculate those, the plus version and the minus version. Over the page. Now, we're not going to go through developing the quadratic formula. The quadratic formula comes from taking our general form of the equation and following all of the processes of completing the square. Okay. And then once you're finished, you have a formula to determine what the roots of an equation, quadratic equation, would be without having to factor or complete the square. Okay. The formula works out to x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So when you have a general form equation, just like the one on the left-hand side there, I can take my a, b, and c and substitute it into the quadratic formula to determine the roots or the x-intercepts or the zeros of that quadratic formula. So let's use that. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. A is 2, b is minus 8, c is 5. Minus a minus 8 plus or minus the square root of minus 8 squared minus 4 times 2 times 5 all over 2 times 2. Simplifying a little bit, that gives me 8 plus or minus the square root of 64 minus 8 times 5, 40. All over 4. Gives me 8 plus or minus the square root of 24 over 4. 24 over 4 is going to simplify. It is going to simplify 3, 4, 2 root something. Did I mess something up? No, I think we're good. 24 simplifies to 2 root 6. 8 plus or minus 2 root 6 all over 4, I mean, sorry. 4. Cancels by 2, by 2, by 2. That gives me 4 plus or minus the square root of 6 all over 2. And then you'd be done. So a little bit easier to get to where you need to be. Okay? A little bit. Depending on the question, a lot. Over the page, just tells you what the quadratic formula is, and then it goes into some examples. I'm going to do one example. Maybe I'll do 2. I don't know. Let's do B. I'm not going to do A. You can do A if you want. You can do A if you want, and you should get to -1 plus or minus square root 2. Here's B. Maybe I don't want to factor. Maybe I don't want to try completing the square. Maybe I'm allowed to use the quadratic formula. Okay, I'm going to go x is equal to minus b. I'm going to write my formula plus or minus the square root of b squared minus 4ac all over 2a minus 12 plus or minus the square root of -12 squared minus 4 times 4 times 3 all over 2 times 4 gives me 12 plus or minus the square root of 144 minus 16 times 3, 48 all over 8 equals 12 plus or minus the square root of 96 all over 8. Does 96 simplify? 16 times 6? 12 plus or minus 4 root 6 over 8. So somewhere over here, you're simplifying 96 by doing your tree. All of these divide by 4. 3 plus or minus square root 6 all over 2. And of course, if you need the decimal numbers, you'd plunk a +1 and a -1 into your calculator. You'd go 3 plus square root 6 all over 2 and 3 minus square root 6 all over 2. I think this one gives you 0.3. This one gives you 2.7. Okay. And then if we go to example C, I'm going to start example C. I'm going to leave it for you to finish. This does not look like our normal parabola, so we need to make it look like our normal parabola. I'm going to bomb the 3 in. 4x squared equals 12x plus 15. Then I'm going to move everything to with the x squared. So I'm going to subtract 12x, subtract 15, gives me 4x squared minus 12x minus 15 equals 0. And then you could go through your quadratic formula. When you go through your quadratic formula, you should end up with 3 plus or minus 2 root 6 all over 2, which works out to decimal numbers 3.9 and -0.9. Please do that work. Please test it. Please try it to make sure that you can answer that correctly. And I'm going to leave I'm going to leave example 7. I'm going to leave example 7. That is going to be the one I'm going to be looking for to make sure is complete with the notes as well. You should be able to get to 1.55. It's supposed to be a 1.55. 1.55 and negative 0.22. So I'm going to be looking to check that one, or we can go over it in class if someone reminds me, whatever it happens to be. So quadratic formula is a quick and easy way, fairly quick and easy way to find your zeros or your roots of your quadratic equations, saving you the grief of having to complete the square or factor. And it will work whether it's factorable or not, okay? Takes us to the end of lesson 6. We're going to talk lesson 7 about the discriminant, which is part of the quadratic formula and what it means. Takes us to, and then that's the end. Then that's it. Okay. We will see you next time.